Anything. So tell me what is Newton's first law, anybody? Here we are here to interact with you, give you some information on what we do, and tell something about our universe. At the same time, we want to learn what you know, so that it will help us how to talk with you. So you all know the Newton's first law, right? What is that? If you keep a body at rest, it will stay at rest unless or until it will be given an external force. This is just a simple law in physics, and we studied from like 5th class. Now when we go into the night sky, or when we go outside, what do we see outside first? We see ground, we have a lot of playground, and when we see just opposite, you see a lot of clouds. Because it's daytime, you are not able to see any stars. But if you go into the night sky, that means if you are in the night, and some of you are from villages, or some of you are very far from cities, so there probably when you go in the night time, you have two important things. One is lot of insects, and the other thing is lot of stars in the sky. So have you ever thought why those stars are there? You can answer. This is just an interaction. Treat me as your friend. You can freely talk. Huh? Please. It will be more nice if any of you can shout the answers. Anything, right or wrong, it doesn't matter.
All of you have had breakfast in the morning? Yes. So you can talk. So the more you talk, the more we talk.
And more we all together can enjoy the talk. It's not a talk, it's just a discussion. So did you ever think why there are stars? Okay. Let's talk about why there are stars. So before going to why there are stars, we have to understand something else also. Now, this is a talk about why there are stars, basically, and how they came about, and what is our current understanding of these stars or other things in the night sky. So let's start talking something which we already know. Do you know what is the human temperature, average human temperature? If you have a fever, then what you do, you put a thermometer and test how much body temperature you have. But if you don't have any fever, if you keep the thermometer, what will be the average reading that it will show? 98.4 Fahrenheit. So the same number, if you convert into Celsius, do you know what it would be? Yeah, say 35 or 32 to 35, let's say. Now, one of you, any of you, just come here and write number 35 here, or 32, write 32. Just write 32 here. So, do you all know a number raised to a power, another number, x power y? If you have a number x, and if you want to raise it to a power y, let me put it this way. If you have a number 2, if you want to raise it to power 2, that means 2 power 2. What is 2 power 2? 4. Okay, let me write. So 2 power 2 is 4, right? Now 2 power 3 is 8. That is basically 2 times 2, right? Now what is 10 power 2? 100. In this form, 10 into 10, or basically 100. So that means when you have power 2 here, those many zeros are there in that number. So now you come and write a number which is 10 power 32 here. 10 power 32. So 1 should follow by 32 zeros. You all count how many zeros there are.
8.
Oh, it's okay. You continue from the down. You cannot write it here. Is over 32? Add one more zero to that. So this is what our human body temperature in Celsius. Okay, you can see it. And you know what this number is? Can you guess? Any wild guesses? Huh? Yeah, tell, anything is fine, just tell.
It's converted into Celsius.
No, it is actually the temperature of the universe when it was 10 power minus 43 seconds. So can you see the comparison between these two? Our body temperature is just 32 degrees centigrade and universe temperature when it just took birth was 10 power 33 degrees centigrade. Can you imagine what that number is? If you have, let's say, 1 rupee in your hand and if she has 10 rupees in her hand, so how much more rich is than you are? 10 times richer than you. And if she has 100 rupees, how much rich is she than you are? 100 times. So our body temperature is 32. You can, let's say, it's equal to 10. Doesn't matter. This is 10 power 32 times. The universe was 10 power 32 times hotter than our body temperature. That is the temperature of the universe when it took birth. So now we will talk about universe. This is just a 15-minute talk. I see that you are very silent and good, but we don't want that. We want you to shout answers. I know your professor or sir is sitting there, but don't hesitate. Just shout answers so that we can all enjoy together. So I will talk about the evolution of the universe from its birth to its 3 minutes stage when universe was 3 minutes older. Okay?
You was explaining about stars.
Yeah, I'll explain. After that, you ask me the questions. Okay? Then we will slowly get into the stars and why we see stars. Okay? Now, so there was something called a Big Bang. You all know about Big Bang, right? You heard of Big Bang? What Big Bang? So what was it according to your understanding? Anybody, please answer. Anybody?
Even if it is wrong, it's okay.
Yeah, it doesn't matter. Big Bang, it's a cake shop outside. It doesn't matter. Anything that you know about Big Bang word that you are aware of, just tell. Tell. Sorry? YCT? Oh, it's in a game. Okay. According to one person, Big Bang is equal to game. So any other?
Universe expansion.
Universe expansion, okay. Any other alternatives for the word Big Bang that you can think of? Basically, the word suggests that there is a bang. Bang means, you celebrate Diwali, right? And somebody burn crackers, so it makes sound boom or something like that. So that's basically the word bang here. And big there means it's really big. The sound or the energy or whatever it produced in that cracker, it was really big. So it was the Big Bang that created everything that you see today. It created you, it created me, it created this candle, it created this chalk piece. Everything that is there in this universe now is because of that single big explosion. So when there was explosion, the initial temperature of that explosion was about these many degrees centigrade. That means it was really hot. But do you know how small that explosion was or how tiny the explosion was contained in? Let's talk about this. You all burn Diwali crackers, right? So there are these red colored crackers where you burn them and then they just give top sound. How much big they are? Basically something like this. On an average, this, let's say it is 10 centimeters. Okay, chalk is 5 to 10 centimeters. For your understanding, I'll write 10 centimeters. You all studied physics. You are studying physics. You know there are atoms, right? What are atoms? One of the smallest entities in this universe. So atoms consist of protons, neutrons, electrons. They basically have a nucleus. In that protons and neutrons are there, and surrounding them are electrons. Okay. Do you know what is the size of this atom? Can you tell what is the average size of an atom? Let's say, for our understanding, it's about 10 power minus 10 centimeters or less. Okay. So all the universe that we are seeing now today, all the stars, were once smaller than this size. Okay. That means if you make this 10 power minus 10 pieces of it, if you make this chart piece 10 power minus 10 pieces, that means, let's say this is one piece, this is two pieces, this is four pieces. Like that, if you continue to divide this, you will have 10 power 10 pieces at some time. Okay? That is the, and you can have size of that. Basically, can you see the dot here, right? A small dot that is there. The size that we are talking about will be million times smaller than what the size here is, or even smaller than that. So you squeeze everything that we see today. You squeeze your friends, you squeeze all the benches and all those things into the tiny dot. That was the size of the universe when it started its journey, or when it took birth. So we have two numbers now. One is the temperature of the universe, and one is the size of the universe. Now, after it took, nobody knows why it exploded, or nobody knows why the Big Bang took place. There are several theories which you will learn when you grow into studying physics in an advanced level. That means after you finish your 10th class, you will do your PUC, and then somebody will do engineering and somebody will do Bachelor of Science. So during that time you will understand that nobody knows why the Big Bang explosion took place, but there are several explanations, possible explanations for that. Now after the explosion, something very important happened in the phase of the universe. Till now the universe is only of this size, remember. Okay? But after the explosion happened, something very unique happened. Now let's start talking about something else that you know. So when you run, you all run on the ground, right? For your school games. So in 1 minute, how far you can run? Do you know, or can you just tell any number? Can you run 10 meters? Or you can run more than that? Okay. Okay, in 1 minute, let's say you run 100 meters. So that is your speed. That means 100 meters you are running in 1 minute. 1 minute is nothing but 60 seconds. Right? So that means 60 seconds you are running 100 meters. That means in 1 second you are running 100 by 60 meters per second. Right? This is about, let's say, 1.35. That means you are running at 1.35 meters per second. Somebody will run faster than you, somebody will run slower than you. But all people will run above 1 meter per second. Now you all, do you have any watch? Anybody has a watch here? See 1 second time, how long it takes? It takes 1 second. Right? So basically you blink your eyes. That is kind of 1 second. All you can blink your eyes. Just blink and see, feel how 1 second is. You understood what 1 second duration is. So in this 1 second alone, lot of important things happened in the universe that allowed us to stay in the classroom today and talk like this. Any alternate things that would have happened during that 1 second, things would have been completely different. So we will talk more about that 1 second now. So we all run around 1 meter per second, right? Now, do you know what is the fastest thing on earth? Anything that you know, fastest thing, the word fast associated to huh? Cheetah. One is cheetah. How do you know how fast it runs?
Per hour 45 kilometers.
Okay, well, let's say per hour 40 kilometers. So the number he told is 3 times smaller than what cheetah can actually run. Cheetah can run about 120 kilometers per hour. That means it's like you have a car. Some of you have cars and some of you have cycles. Cycles, when you ride cycles, you will be going slow. But when you see cars, they are going very fast, right? And these trains and aeroplanes go even faster. So let's say on Earth, the fastest thing is a bullet train. Bullet train goes on about 400 kilometers per hour. Right? 400 kilometers. You know how to convert from hours, kilometers per hour to meters per second? Do you know how to convert from kilometers per hour to meters per second? I will just tell a simple way. 400, 1 kilometer is 1000 meters. 1000 and 1 hour is 16 minutes and 1 minute is 60 seconds. Okay, this is what. So you can cancel 0, 0, 0, 0, right? And then let's say instead of 400, put 360 here. 6 into 6. Now you can cancel this 36 here, and you have 10 and 10. So 100 meters per second, right? Now this is the fastest object on Earth. Let's say a bullet train. Do you know what is other? Do you know any other fastest objects in this on this Earth? You have all torchlights or candles in your home. Okay, you have laser light. So when you switch on laser light, that light hits the wall, right? You see a small dot there. And do you know how fast it travels? What is the speed of the light? Do you know? Speed of the light. You must be reading it in your physics class. Speed of the light. Any number? Yes? Tell loudly. Yeah. So your friend knows what is the speed of the light. Speed of light is 3 times 10 power 8 meters per second. This is the speed of the light, and 100 meters per second is speed of the fastest object that you know, which is a bullet train. 100 you can write 10 power 2, right? Just simply divide this with this. There are 8 zeros here and there are 2 zeros. So 6 zeros. So light travels this many times faster than a bullet train. It's a big number, right? Now this is what the light travels. But we should come back to Big Bang. So I told during the birth of Big Bang or the birth of universe, it was this hot. And from this time to this time, let's say this is when the Big Bang took place, and this is when we are talking about now. This is actually a very small number. This is much smaller than a single second. So this is, there are 43 to 36. How many zeros will be there? I want answers so that we can do better job. Huh? 7, right? So this is 7 times smaller than this. But all this is 1 second. These are all in seconds. So 1 second is 10 power 43 times larger than the instant when Big Bang took place. And 10 power minus 36 seconds is 36 times smaller than 1 second. So during this time, that means much smaller than your blink of eye. Okay? In 1 second, I said you can blink once. Let's say there is another creature, he is blinking the eyes. that much fast it will be. So during this time, the universe, which was initially 10 power minus 10 centimeters, okay, it expanded to almost 30 times the size of this, 20 times. That means from 10 power minus 10 it went to 10 power 20 centimeters. So almost 30 orders of magnitude it expanded. I want you to understand what this means. Somebody can come and just write how many zeros are there in this expansion. Would you like to do that? Here there are already 33 zeros. Just remove 2 zeros or 3 zeros. In this time, that means in 10 power minus 7 seconds, the universe expanded to this big. From a tiny particle size to a size which is much larger. In fact, that large size is as big as our galaxy. Do you all know the name of our galaxy? What is it called? Milky Way galaxy is a very big galaxy, right? So from one side to the other side, light takes almost 30,000 years to pass. So these numbers, why I am giving you is because they are very big numbers, and this is where the fun of science lies. You should understand what these big numbers are all about. So we are talking of very extreme cases that can be never reproduced in a classroom laboratory. Okay. Now after Big Bang took birth, Big Bang happened, that means universe took birth. Within this size, for some reason, it expanded to the size of a galaxy. So during this time, what happened? There were some problems in the expansion, you can say. Let's say you are expanding a balloon, right? You know, you have a balloon and you can expand it. When you expand it, it expands smoothly. Okay? Let's say you have some sort of water tray. Okay, water. And then you create ripples in it. That means you bump a stone in it. It will have some ripples. Now, let's say when it is rippling, you expand it. Okay? And instead of water, talk about some sort of mud. Okay? Very soft clay or mud. And you throw a stone in it. So what happens? The place where it hits the stone, it will be a dip. And some other places, it will scatter all the ejected material, right? So, and let's say you expand it. Those ejected materials will be there only. And this core that it went through will also expand. So, in the expansion process, at some places, something got accumulated more than the other places. Okay? So, that is basically energy or density which was accumulated at some places more than the other places. And fortunately or unfortunately, those places were fixed forever. That means you have a place like this, and let's say you have some disabilities in the place, and then you expand this place to a size of this. Those disabilities are still there, they just grew in size. Okay? You are following, right? If you have any doubt, just ask me. So, something like this happened in the early universe. That means we are talking about a size time of 10 power minus seconds. That means even smaller than your blink of eye. And then you all know protons and neutrons and all. Right? What are those? Protons are positive charged particles and neutrons are neutral particles. Electrons are negative particles. So, during this time, nothing was there. It was just energy. No proton was there, no neutron was there, no electron was there. It was all pure energy. Energy means it can also be light. You know, light means energy only. Photons are form of energy. You all read that, right? So, during this time, there was just energy. And also this type of problems in the expansion. Now later, once the temperature cooled to some level, we are talking about 10 power 33 Kelvin or 33 centigrade. So nothing is stable in the temperature. That means if you all go to kitchen at your home and your mom is making something, rice she is cooking, and if you want to touch the rice bowl, what will it be? And can you keep your finger there for long? Because you cannot take that much of temperature. Your fingers will start hurting. So that means when the temperature is more, things cannot be stable there. Things will be moving very fast. But the temperature of the universe was 10 power 33 centigrade. That means it's very hot than the rice bowl in your kitchen. And even protons cannot put their fingers in there. It was so hot for them. But once the temperature cooled to sufficient degree, that means when the rice cooled to your regular lunchtime rice, but you can start eating, right, without any problem. Similarly, when the temperature of the universe cooled to some temperature, protons felt, okay, now we can form. So how they form? They form from the existing energy. Okay, in these problematic locations, they started forming there. Similarly, neutrons also felt they can form. They also started forming. And similarly, electrons formed. So they all form from energy, pure energy. Now, once these form, is it sufficient or do we need more? Once the neutrons are there, once the protons are there, once the electrons are there, what else we need? I mean, what is the next step in the creation process? We have protons, we have neutrons, and we have electrons. If you all bring these together, what will happen? Atoms will form. So we already know that atoms will have some protons, some neutrons, and some electrons. What is the simplest atom you can think of? Basic atom. What is the first element in the periodic table? Hydrogen. Hydrogen has how many protons? One proton. Hydrogen has how many neutrons? Hydrogen has no neutrons. Only one proton. And hydrogen has how many electrons? One electron. So hydrogen is one proton plus one electron. Right? So once we have protons, neutrons, electrons, they are ready to form hydrogen atoms and other atoms. What is the next element in periodic table? Helium. So helium, tell me how many protons, neutrons, and electrons? Then two neutrons. So helium has two protons, two neutrons, and two electrons. So we have protons, neutrons, and electrons. But when they formed, the universe was very hot for them. That means, again, it is like your kitchen and rice bowl. Some person can eat with hot food. Some people cannot eat that much hot. They want it to be cold. Like some people want to drink cold milk. Some people want to drink hot milk, because people who want to drink hot milk can bear the temperature, right? People who want to drink cold milk, maybe they don't like hot milk or they don't want to drink that much hot, so they will and then drink, right? Same way with atom formation also. The hydrogen atom thought it was too hot for it to form. It didn't want to form that time, because if it formed, it was getting destroyed immediately. Why? There was so much of energy that electrons were not able to stay with the proton. They were just going apart. Only when you have a proton and an electron rotating around the proton, you can have a stable atom, right? That's how hydrogen atom is. But if the electron is not willing to stay with the proton, what will happen? Proton will be very far and electron will be very far. Even though if they are close together, they don't want to stay together. It's like two friends who don't want to talk because they have fight. So till then they are good friends, but after some fight they will not want to talk. Why? Because there is something in between them that is not allowing them to talk. Same way, there was something during that time which was not allowing a proton and electron to form an atom. That was the temperature of the universe that time. It was so hot that they don't want to talk to each other. But as the universe is expanding slowly, the temperature of the universe started coming down slowly. So it is same thing. You have hot air, okay? You all know this motorcycle. Motorcycle has these silencers. You know, right? Silencer is like that big rod from where this smoke comes. When somebody is running a motorcycle, if you keep your hand very close to the silencer exhaust, do you know what it will be? It will be very hot, because the air that came out of that nozzle or the hole is just experiencing the outside temperature, and in the engine it was very hot, so the same air came out and then it is heating your hand. But let's say you keep your hand slightly away from the silencer and you are still feeling the smoke. Do you think it will be hot or cold than the closest point? Cold. Because once the smoke comes out, it starts to expand, right? Once it expands, it starts to cool down. Okay? So it starts to cool down means its temperature reduces. Same way with the universe. Once the universe started expanding, initially it was very hot, 10 power 33 times hot. By the time the protons formed, it was only 10 power 9 Celsius. See how big drop it was from 10 power 33 centigrade to 10 power 9. What is the difference between 33 and 9? 24. So universe cooled by 24 times. 24 orders of magnitude it cooled. Okay. After protons formed, it was 10 power 9 degrees centigrade. But hydrogen thought this temperature is too hot for it to, form an hydrogen atom. So it was not forming. The universe expanded further, and then the hydrogen thought, okay, now the temperature is cold enough that I can form. That means a proton can talk to an electron and they both can stay at the same place. That's when the hydrogen formed. Same way, helium also formed. That means two protons came together, two neutrons came together, and two electrons came together and formed a bond. So that became a helium atom. So this was like this for several thousands of years. Okay. So the universe was just hydrogen gas and a little bit of helium gas and lot of photons. Photons are nothing but energy. Okay. So that time the universe temperature was about 3000 degrees centigrade. So from there 10 power 9 degrees centigrade it fell to 3000. 3000 means 3 times 10 power 3, right? So it fell by 10 power 6 times. You understood how it added. So it became this much cooler. So let's understand what this temperature is. You all must have gone to repairing your cycle or repairing some steel rods. Okay, there are welding shops. Welding shops, they put a mask like this and they will have some sort of gun in their hand and they will trigger and sparks will come. Right? Some people will trigger and some sort of flame will come. You all are aware of that? So this temperature is close to the temperature of the welding machine or welding flame that is coming out. So the universe was that hot. Can you live in a universe which is that hot? So what is the temperature outside now in Bangalore? Can you go? Let's say 25 degrees centigrade. Right? 25 to 30 degrees centigrade. But universe was 100 times hotter than that. So everything was very hot on an average. And then remember these problematic regions are there still. Those are expanding. Those are accumulating more and more mass. Now when a body has certain mass, what is the first thing? Do you all know about gravity? So what is gravity? Gravity is the attraction exerted by a massive body on another massive body. That's why when I drop a chalk piece like this, it will fall on the ground. It will not fly away. That means gravity is pulling the chalk piece towards the ground. Same way, when there is more mass that is coming together, it will start attracting each other, right? And then it will start forming big balls. Just like if you have a cricket team and when there was a wicket, everybody will come together and do a hurdle. You all know that. You watch in T20 and World Cup matches. Same way, when the gravity is when the mass comes together, gravity will attract more and more mass accumulates there. And basically that time only hydrogen was there, right? So it all started coming together. Now I will clean the board and let's see how star formed. Did you follow till this point? Yes. Before I rub this board, just ask me question if you have any. Ask. You are very silent. Any doubts till now? Earth is? Yeah, we will. Since we have not come to the Earth yet, we are still forming the stars. I will write the question here. Earth. How it formed. Okay. So that we will come to when we are close to the formation of Earth. But do you have any questions till hydrogen atom or helium atom or what temperature or any numbers? No? Okay. So you have the hydrogen, that means one proton and one electron, and lots of them, right? They all started forming a group. Like that, they all started forming several groups. Okay? So let's say you have a area like this or a region like this. It's like a park, okay? And there are several children playing. Children playing. Now if you reduce the area of the park, children will play at smaller regions, right? Same way, let's say you have a bus which is packed with some people. If you reduce the size of the bus, so many people have to sit within the same size bus. Let's talk here. You have a bus size and there are 1, 2, 3, 4, 5, 6 people sitting in the bus. Now for some reason, you reduce the size of the bus. What happened from here to here? Congested. So people started sitting very close together. Now if you reduce the size of the bus even further, people will be sitting on top of other person. Okay? That means they are very close now. Let's say a region like this which is filled with hydrogen was getting reduced. Okay, what is reducing the size of that? Just now we talked till now. Something acts on a massive body. What is that? Gravity. Because of the gravity, everything was coming closer together. Okay? Let's say you have a big ball and you are squeezing that ball. What will happen? The ball size will reduce. Right? That means you are applying external force for the ball to reduce. You understood? Same way, once the hydrogen accumulated in some region, because of the gravity, it started accumulating into a smaller and smaller size ball. Now, let's go back to bus. If you reduce the size of the bus even further, what will happen? They will sit so close and they will start fighting with each other. Right? They will start interacting more. I want this seat, I want this seat, and then they will start punching each other. Same way, when the gas which was filled with hydrogen was brought so close, the other hydrogen atom can see the other hydrogen atom, right? Because they are coming closer and closer. So hydrogen atoms can now talk to other hydrogen atoms, and then they can interact with each other. And then they are moving very fast, and then they are bouncing each other. So when a hydrogen atom is going, one hydrogen atom is going this way, and another hydrogen atom is going this way, and then they will interact with each other. So with this interaction, something very interesting happens. Now, do you know about nuclear fission or nuclear fusion? Nuclear fission or nuclear fusion? Do you know in our periodic table there are elements like uranium, polonium, thorium, right? There are what rare earth elements or radioactive elements, right? Radioactive means they have some sort of activity. That means